Paul, what role does performance and availability play in database architecture?
This is a question that has many facets. The first thing you really need to do is decide what kind of applications are accessing your data. Now, a database really is nothing more than an organized collection of data. It can be used for many, many purposes. E-commerce, financial reporting, online trading. The possibilities are almost endless. So the first thing you really have to do is decide what the nature of your users are. What kind of response do you want? Do you want fast response to requests, individual requests to do things like submit an order? Or do you want very good, what we call throughput, which means a great deal of work being done in the shortest amount of time? That's step one. You really have to look at your application. And these are the things that we do when we go into a customer site. Second thing you really want to do is look at the kind of systems you'll be running on. And you want to match the capability of your system to the load that your database is going to put on it. In many cases, it doesn't do you any good. In fact, it can do you harm to buy too much computer hardware for the application that you have, because the overhead of running that hardware can detract from the database performance. And the third, and I think most critical and most labor-intensive portion, is where you design your database layout. And this means a database really is just a collection of files on disk. The way that you're going to lay that out across how many disks, with what kinds of performance characteristics, accessed by what kinds of different machines, is really going to make the difference in how you see your performance scale with more demands placed upon it. Then you can get into more esoteric issues such as the database tuning, the way that the database software is actually deployed and configured. But it's really a multi-step process, and you really have to look at the right pieces and in the right order for it to work.
Paul, I understand that databases are now playing a much bigger role in systems, and they're much more versatile than they were just a couple of years ago. Tell me about that.
It's always been possible to search for particular information in a database. But what hasn't been possible is the ability to search for information in very large documents. So let's say that a company has a database of job applicants, and stored in the database are the resumes of job applicants. It's not enough simply to look for, in a typical conventional database technology, to look for all instances of particular keywords or skills in this resume database, because the volume of the data means that the old straightforward searching capabilities, while they will work, will take far too long to be practicable. So many database vendors now provide a full text search engine in the database itself, rather than asking or requiring the customer to build their own text search engine. Another type of add-on capability now is what's called messaging. And this is simply a way for certain processes within a system to be publishers of messages, and for certain other processes to become subscribers to messages. So you might see in a stock trading application, for example, you might have a producer of messages be a system that receives orders from customers connected at their PCs or their terminals that are issuing orders to buy or sell securities. You might have then the subscribers to those messages being what might be called the order servers, which take those orders and route them to a destination, such as an electronic exchange, where they will be executed. It's very important to have a very flexible messaging system so that those messages can be shipped off to their destinations and consumed by the processes that are interested in them, without having those processes be very, what we call, tightly coupled, meaning dependent on one another. So you have sort of a middleman whose job is to receive and transmit. And a database today can take care of much of that functionality, so that the customer does not have to write his or her own messaging system. Database gives us what's called the queuing capability, so that messages can be really queued up in a line, just like you wait in line at the deli, and served when your number that you've chosen off the number dispenser comes up, then it's your turn to be serviced. The database technology now can do that, and this is really beyond what databases have typically done. I think the reason that customers are finding this to be an advantage for them is that when you're running a relational database that is holding the information for your enterprise, there are certain things you must do for that database. You must tune it so that it runs fast and efficiently. You must make it redundant so that, as I've mentioned earlier, there's no single point of failure. You must back it up, which means you must copy it to secondary storage, such as another disk drive or a tape drive, periodically, to guard against an ultimate sort of disaster wherever you have real destruction of your systems. Once you have all of that infrastructure in place, the more you can use that database for, the better, because you don't have to duplicate any of that effort. Now, you've already got it in place. This is the place where our corporate data resides. Let's use it as much as we can. And this is something that we really try to advocate for our customers, is to get the most, leverage that investment you've got.
John, Digitask specializes in high-performance, high-availability environments, and I know you use a variety of operating systems. How does this really benefit your customers?
The benefit can best be illustrated through a story about a project we did for a major mutual fund company. They made a strategic decision to move their data warehouse application from a legacy system to a modern Unix cluster. They came to Digitask because of our experience with multiple cluster operating systems, including Unix. We provided the client with a no single point of failure configuration using redundant systems, system interconnects, storage controllers, and data paths. In addition, the storage itself used RAID 0+1 to achieve a high-performance, highly available environment for their Oracle Parallel Server database. At the time of implementation, the Unix clustering technology was shifting its paradigm. Digitask and the manufacturer provided the client with the opportunity to take advantage of this shift prior to it being released for production use. The new technology allowed Oracle Parallel Server under Unix, providing concurrent database access from any machine in the cluster. Digitask implemented the newer technology for the client, enabling them to have a reliable working application and designed and implemented when the Unix server clustering technology was released.
Digitask has a range of expertise, and I know it ranges from systems management to data center operation and design. What can you tell us about them?
Digitask consultants recently assisted an insurance company in the design of a new data center and managed its construction and implementation. This client had outgrown their 1,100 square foot computer room's capabilities. The available power was inadequate, the wiring was strung from the ceiling, and any addition required a scramble for space and ran the risk of overloading the circuits. This actually happened more than once. The new data center had to be designed to work with an expanded but a limited space and provide an estimated 5 years growth. We were able to increase the available space for systems and storage by more than twice while providing a state-of-the-art command center and a lab area. The client had previously had a limited but inadequate lab area and no command center. Much thought and coordination went into designing the new space for reliability and functionality. For instance, each server cabinet has redundant power from separate UPS-backed power sources. Each cabinet has been pre-wired with 18 level 7 copper data connections and 6 pairs of fiber optic cables. There are 15 locations in the data center floor and 4 command center positions where system administrators have access to the console of any system in the server farm. The design Digitask consultants provided gave this client a modern, highly available, highly reliable data center. The implementation occurred without impact on production processing.